Good day. Today we're going to have a look at multiplication and division with exponents. If you haven't gone through the exponential rules from our previous video, please do that before you carry on. And then we're going to look at the simplest way to work through a multiplication situation or a division situation, remembering always that this line, this fraction line, means division. Right, so if we have a look at this multiplication, what we're going to do is we're going to do a kind of thought process to get to the final answer by looking first of all at the signs, then the coefficients, which are the numbers that stand in front of the variables, and then we're going to process the variables remembering the exponential rules. So this encompasses quite a few things. It encompasses multiplication tables, it encompasses the rule of signs from integers, and then the exponential rules. But if we go step by step, we're going to get negative times positive is negative. 3 times 2 is 6. Then we have two different variables. So let's work with the variable first of x. So both of them have got a base of x. So we're going to have a base of x. And then just remember, if a variable does not have an exponent written in, that exponent is automatically a 1. We don't write it in, but you have to remember that it means x to the power of 1. So x to the power of 1 times x to the power of 1, according to the rules, if we're multiplying two variables together, or two powers together with the same base, then we need to add the exponents. So 1 plus 1 is 2. This power has a base of y, and there is no other power with the base of y, so it's not going to be affected by anything else, and it's going to remain y to the power of 3 or y cubed. And that's how simple it is if you just process the signs, then the coefficients, and then the variables. So let's do the same thing, but with a division question. So remember, if there is no sign in front of a number, it means positive. Positive divided by negative is negative. 4 divided by 2 is 2. And then when I'm dividing powers, I have to make sure that they've got the same bases, so I can process the ones that have got a base of m. And when I'm dividing powers, then I have to subtract the exponents. So 2 minus 1 is 1, and I'm not going to bother to write it in. And then here I've got powers that have a base of n. And then dividing those powers, I need to subtract those exponents. So 5 minus 2 is 3. So my answer is negative 2m n cubed. We can have a number of things multiplied together at the same time. So let's take negative 7 p squared q. Remember, brackets mean times 2p. And then I'm going to have another thing multiplied, a negative 2q to the power of 5. So going step by step again, negative times positive is negative, and negative times negative is positive. Or you can start seeing that a negative times a negative is going to give me a positive, and then because the other one is also positive, it's going to be positive. Looking at my coefficients, 7 times 2 is 14, and 14 times 2 is 28. I have powers with a base of p and also powers with a base of q. So first of all, looking at the base of p, p to the power of 2 times p to the power of 1, add the exponents, 2 plus 1 is 3. My base of q, this is q to the power of 1 and q to the power of 5. Multiplying them together, I add the exponents. 1 plus 5 is 6. And that's my final answer. One last one, also with division. Negative 16 x to the power of 8, y to the power of 5 over negative 4 x to the power of 6, y to the power of 5. Starting with my signs, negative divided by negative is positive. If you write a positive, that's fine, but you don't need to. 16 divided by 4 is 4. Then here I have 2 with the same base of x. I'm dividing, so I have to subtract the exponents. 8 minus 6 is 2. Then I have 2 powers with the base of y. Dividing them, I have to subtract the exponents. So I'm going to get y to the 5 minus 5, which is y to the 0. And if you remember that exponential rule, it says that anything to the power of 0 is 1. So in my answer here, it would actually mean 4x squared times 1. Well, when we multiply anything by 1, it remains the same. So we don't need to write a times 1 in. It won't change the value. So what you can actually remember is that as soon as you've got a power that looks identical to another power, in other words, the base is the same and the exponents are the same, you can just think of cancelling the equivalent thing in the numerator with the denominator, because that is going to be your final answer. But the reason why you are cancelling is because that is happening. So I always find it's easier to remember something and how to do something if you know why it's happening than just learning methods off by heart. So to understand why it's happening will allow you to remember just to do that. I hope that has been helpful, and we'll have other videos on exponents bringing in some of the other rules as well.